Thank you very much. Thank you for inviting me. It's an honor. Oh, I was going to say to be here today. Unfortunately, my knee decided otherwise, so I cannot move at the moment. That's why I'm not here. First, I would like to thank the organizer for this event. It's a great opportunity to be with you today and speak about EDF and SMR to such an esteemed representative from Slovenia. So your country has a strong commitment to energy sustainability, and I am really excited to share how EDF and our SMR project New World can contribute to this vision. So first, a few words on my presentation will cover first a bit who we are, EDF, what is in our view the role of nuclear, and what are the specificities and also the fundamentals of SMRs that we can that are key for developing successful projects. And I'll come a bit into what is the EDF proposal regarding SMR with the New World product. So as you know, EDF is one of the world's leading energy company, and we have a deep expertise in nuclear energy, but also in renewable and sustainable power. And I would say we have an expertise actually in managing energy systems. For decades now, we've been at the forefront of energy innovation and also ensuring reliability, safety, and environmental responsibility in every market we serve. So today I am here in particular to discuss about how SMRs in general and New World more specifically can support Slovenia in its energy transition. So New World will combine flexibility, which is key, efficiency and safety in a way that makes it an ideal solution for countries seeking clean, reliable and scalable energy production. I understand that Slovenia has ambitious goals for energy security, decarbonization, affordability and innovation. With your existing nuclear expertise and commitment to sustainability, New World can be a strategic opportunity to support you in your energy transition while maintaining green stability and economic growth. So after this introduction, I will go into more details in the various points. So first, a few points regarding EDF. Hop. Sorry, I need to, yes. So first, I would like to start with a statement which is, in our view, energy is at the heart of the prosperity. And as such, we believe in developing an energy system that works for all in the low carbon emissions, so an energy system that is good for the environment, that is good for people, that is affordable, and that is also reliable and sustainable in various dimensions. So this is really key for us, and we have been always committed to carbon neutrality, and we are offering solutions that in the long run contribute to more resilient and affordable energy system. In order to do that, we have the conviction that electricity is a powerful drive to reach these objectives, with nuclear in the mix alongside renewables and especially hydro, wind and solar. So why nuclear in the mix? I can make very long conceptual or theoretical speeches about that, but I will just actually focus on what has happened. So that's the 2023 numbers. The 2024 number would be even better, which is what is happening today in Europe. In 2023, France has exported 50 terawatt-hours of electricity, of course, but not any electricity, low carbon electricity. So it means that we have directly contributed to reducing the emissions in all Europe. So in the United Kingdom, but also in Poland, in Italy, and in Spain. So we are a direct contributor to the decarbonization and the stability of the system at the EU level. And this is due to our nuclear fleet, plus the hydro, but most importantly to the nuclear fleet and interconnection. So this is what is the reality today. Nuclear is today contributing to the decarbonization of Europe and to the stability. Another point I would like to highlight is we are not exporting base loads, and the nuclear fleet in France is not working base load at all. The nuclear fleet in France is highly flexible, and it can really work together with the solar system and provide the peak that is necessary in the morning and decrease at the middle of the day and come back at the end of the day. So nuclear is flexible and is a powerful tool to decarbonize and provide stability. And it is not me saying this is something that is happening in Europe today. If we look at what is happening, what will happen in the future, EDF has, on the back of the European Nuclear Alliance, to target 150 gigawatts of nuclear at the end of the 2050 horizon, which for a lot of these countries, for the Europe of countries within the Nuclear Alliance, is the only way to reach carbon neutrality at the European level. EDF has developed a scenario to see how we can actually achieve these quite ambitious targets. And so we have developed a kind of this scenario that we call the net zero European scenario. Today in Europe, we have roughly 100 gigawatts of existing nuclear capacity. Taking into account the life extension that are possible, so reaching 60 years life extension, out of this 100 gigawatts, only 15 gigawatts will stay at 2050. Then there are already some new nuclear capacities that have been announced, large units, for example, the French program, the UK, and the Czech Republic, Poland, and some small program regarding small modular reactors. We need to go beyond these new nuclear capacities already announced if we want to target the 150 gigawatt. Why I am saying that? I am saying that because even if, for example, there is a large project reactor in PROSCO today, if we look at the big picture, we need more projects than the project that has been announced today. So we need more projects at the European level than the ones that are already in the programs. So it means there are opportunities for other projects, additional projects to the one that exist. And there are opportunities, and it's also, if we want to achieve net zero with a resilient system, actually, we believe that we need these extra projects. Okay, what is the, so yeah, we believe we need more projects at the European level, not more nuclear projects, and actually EDF, as we will see, is the main contributor to this project today. EDF is not is a bit peculiar regarding nuclear. We do, shall I say, we are responsible players, and we are everywhere on the value chain. So we have our own design. We own that design. It is a European design. All the intellectual property is in France and in Europe. When I say we own the design, we also own the design of the fuel. Let's never forget that in order to run a nuclear station, you need from time to time to put some fuel in. And the fuel is not as coal, is not a commodity. So there is a technology in the fuel, and it is important to make sure that you don't depend on another country actually to manufacture this fuel. In France, we own the design, and we also own actually the technology regarding the fuel. We have an experience in building them. I'll come to that later, because we need to have a conversation about the track record we have at the moment and why we have this track record. We are also, and mainly also, We are the biggest nuclear operator in the world. We have a large fleet, mainly in France, but also in the UK and some partnership elsewhere. And we are a responsible owner and operator and member of all the international institutions. And as a responsible operator, we are also responsible for decommissioning our power plants, and we have a deep expertise on that. We think this is very important. So we have a view of the, I would say, what it takes to be in the nuclear industry, as has the Slovenia, from all the spectrum of activities. So we have actually behind this fleet of 66 reactor, we have 50,000 engineers and technicians within EDF working in the nuclear field. And we also believe that nuclear is not an industry of the past, it is an industry of the future, and we are innovating. We are investing each year 300 million euro in R&D in the nuclear sector, supporting both the existing fleet and innovation for the new fleet. Behind this, behind EDF, it takes a large breadth of competencies, capacities, capabilities to build or operate and decommission these power plants. These are big technical objects, and we are not doing it alone. So EDF can count today of a wide and very, let's say, deep supply chain industry. The nuclear industry is the third industrial sector in France, and it's creating more than 202,000 jobs with more than 3,000 companies in France. What we've learned, so anyway, what we've learned with our experience in Flamanville, in Hinkley-Point-C, during the corrosion crisis, is that even if it's a very strong industry in France, we cannot and we don't want to do it alone. So our strategy at the moment is actually to build a European supply chain, embarking with France all our partners that are willing to develop a resilient European nuclear industry. If we look at what is happening regarding low carbon industries, let's face it, today, what part of the industries are still in Europe? Solar is gone. Wind is suffering and has some big challenges from Chinese already. So the only industry, low carbon industry, that is still in Europe at the moment is nuclear. So if we want to build a resilient industry and a resilient mix, we have to make sure that we know how to build the things we produce. And we believe we should build a resilient European supply chain. And this is possible regarding large nuclear scale. And this is what we are doing already today with the large program. So if I just mention what is happening in Hinkley-Point-C, we are building, we've built a first nuclear station in France, which is called Flamanville 3. It's been a nightmare. We had to restart an industry on our own, and it's been very difficult, but we've done it. Now Flamanville 3 is running. Then we moved to the UK. 60%, more than 60% of the value of the project is actually done by the UK supply chain. So guess what? We had to restart also the UK industry after restarting the French industry. And so now we have this asset. That is, we have already a French industry, a UK and British industry that have relearned how to build nuclear stations. They were very skilled at operating, maintaining a nuclear fleet, but building a new nuclear fleet is different. And the other thing to have in mind is that a nuclear station and even small modular reactors that I developed that are a few hundreds of megawatts, they are big infrastructure projects. And they rely on an ecosystem of industries on the civil part that need also to be strong. And this also has to be thought about. So European supply chain, for us, it's the key, it's the way forward. And we are building it at the moment. The other lessons learned that we have, that we knew, and that we are relearning at the moment, is that these are big projects. It requires processes, supply chain, organizations that are industrialized, that know what they have to do. If you want to be efficient, rather for a small project or a large project, you need to have industrial your processes. Otherwise, you will face many surprises along the way and many events that you have not foreseen. And if you're not prepared, it's going to be a nightmare. Just to give you an example of that, if you want to, the concrete that you use for nuclear station is not any concrete. And in Flamanville 3 and then in Hinkley-Poncy, we spend some time actually trying and testing to have the right mix, let's say. It's a bit like when you make a cake to make sure you have the right mix. It took us some time to do that. Once you've done it once, then you know how to do it. The industry knows how to do it, and it's easy. But in order to have this efficiency, you need to have a pipeline of projects. And this is true for large nuclear. This is true for SMR. This is the same. This picture here is showing what the French industry has done in the past. So we've built in parallel all the French fleet. At some point, we had more than 20 projects in parallel in France. And we were launching sometimes 5 projects every year. And we have done it really efficiently. We have managed, despite the strengthening of the regulatory environment, to maintain the cost of each unit at the same level or even decreasing. If you compare what the French industry has done with, for example, what has happened at the same time in the US, no comparison. No comparison. Having a pipeline of projects, replicating the same design is the key of success. So we've done the French fleet. Then we developed with China a partnership, and now China has quite learned, and they now are building their fleet very efficiently in China. But because we believe of this fleet effect, we actually discussed with the French. So first we did Flamanville 3, which was the first of a kind. And then we developed the Hinkley-Poncy program. And in the UK, from the start, we said to the UK government, please do not make the same mistake as in Flamanville 3, think to build a fleet. And so that's why now in the UK, we have the Hinkley-Poncy program. And just after that, we are in the final discussions regarding the Sizewell-C project. The Sizewell-C project will be a replication of the Hinkley-Poncy program. Unfortunately, Hinkley-Poncy is not a copy of Flamanville 3 because the UK regulator made us make more than 3,000 changes compared to the Flamanville 3 design. So Hinkley-Poncy, new supply chain to start, many changes to the designs that have to be integrated and that put the design quite late, but an opportunity there to develop a fleet in the UK. And so we said to the French government, okay, we need a new program to replace the aging fleet in France. Let's think as a program from the start. And that's why we have launched the EPR, the new French program, which is 6 EPRs plus a potential extension to 8. So we have the basis for a fleet. This is good. This is roughly equivalent to 1 EPR per year. 1 project per year is good, but we believe that in order for any program to be efficient, 2 per year is better. So we are working with our European partner and international partners in order to develop this pipeline of 2 EPR per year. Compared to others, we already have 1, which is there, and we are now building on the second with the UK, with the Czech Republic. The game is not finished there. In Sweden, in Finland, in the Netherlands, in Slovenia. So if I summarize what is key for us in order for a nuclear program to succeed and any nuclear program to succeed, you need a design. You need to have a mature design. That's let's face it, you cannot enter into construction without having your design. You need to have an experience. If you've never built a nuclear station, it might be very hard for you to start. And at the start will be very hard. You need a breadth of capabilities in engineering and industrial capabilities. And EDF, we have engineering capabilities, but we also have industrial capacities. In EDF, we have 2 subsidiaries that are actually making nuclear components that are at the heart of the machine, let's say, what we call the nuclear pressure vessel and the turbine. So we have in-house the capability to develop that. The other thing that we have is we've learned, and this is the way we work, in long-term partnership, and we believe in cooperation. We are not a seller of machines. We believe in building partnerships with our partners. And we have proven that in the UK, for example, and in the 80s, in other times with China. So a long-term approach. Okay, how do we apply that to the SMR? First, a few words, or should we do large scale or should we do SMRs? So if you believe, if you heard what I said at the beginning, you know already the answer. The answer for me is both. There are not enough space, enough lands, enough communities, enough space that are able to host large-scale reactor in Europe at the moment. Nobody is opening new nuclear sites in Europe at the moment. It's a hard decision. Generally, when the nuclear station is in place, everybody loves it, but you need a lot of space. A large reactor is very powerful. So in order to maintain the safety in all cases, you have to take some precaution of what is around the nuclear station. So for all these reasons, we believe we cannot go at the end of the road only with large scale. So for us, SMRs is a great opportunity. For example, if you take Stonehenge, or if you take a lot, actually there are thousands of sites like that. You have coal stations there. They have a coal station, they need water to be cooled. They need grid to evacuate their energy. So you have some infrastructures that are there. And we looked at the European level, and actually there are a wide range of sites that would accommodate with 1 or 2 SMRs much more simply than with a large power. So SMRs is a great solution to replace fossil fuel power plants in Europe, especially in Europe. The other thing is because they are smaller, they are less powerful, so they take less space, and they work better within an industrial ecosystem. So you can put them closer to industries, and they can provide electricity, but also heat, steam to these industries. So it's another great asset. And the last but not least point is that if I'm in the shoes of a TSO, so for example, in Slovenia, it's easier for them to manage a system with many 400 megawatt units than with a large 16 megawatt reactor, because then it's easier to evacuate the power. It's easier if there is an issue to balance the grid. So for all these reasons, SMRs are the right solution in many countries in Europe. Okay, this is the S. SMR is SMR, small modular reactor. So S is small, but S is also simple. Because it is smaller, you can and you need to make it more simple. And because it is simple, you can standardize and you can decrease the cost of construction. Okay, and all that the first. So S is small and simple. The other thing is that because it is smaller, you know, we didn't build 16 megawatt reactors because we wanted to have the biggest one in the world. Actually, all the nuclear industry, we started with small reactors. So, for example, in Crosco, you have a power plant that is closer to now what we call small modular reactors. If you compare Crosco output with, for example, what Rolls-Royce is proposing, it's not that far away. So we started with small and we went bigger to have what we call economies of scale. For example, designing a 16 megawatt reactor or designing a 400 megawatt reactor is more or less the same work to do. It costs billions. If I spend billions and then I have a big object, it makes sense. I mean, from an economical perspective, it might make sense compared to spend billions in the design that is a small object. So in order for small modular reactors to be competitive, you need to reflect this scale effect with the series effect. So you need absolutely to think about how you can simplify your design. We discussed that, but also industrial, how you're going to build it. You need to do that. You need to standardize to industrials in order to have something at the end that people can actually pay and that is affordable for them. So the idea is to make it modular, to move a maximum of activities out of the site in a factory environment, pre-assemble in factory, and limit as much as possible what is done on site, because that's where all the surprises come, okay? So that's the key. It reduced the construction time and it reduced, more importantly, the risk. And in the same spirit, we are working to prefabricate as much as possible. The same idea, limit as much as possible any surprise of what is happening in a site environment with a lot of uncertainties and risk. Okay, so this is basic principle, and this is what we are applying in New World. So New World, we decided, we started some years ago, and as everybody, we started in a road, and then we learned, and now we have now entering a new phase when we've decided to build the New World on existing. We don't want to take any risk with the technology. As I said, the most important thing is you know what you're going to build. If you have innovations that are not proven, this is great from the R&D perspective. From an industrial perspective, if you want to lower the cost, this is another challenge. So New World is going to be built on existing technological bricks. And what we are working hard on is how to make these bricks modular, simpler, modular, and prefabricated. The other point is from the start, this is a very standard picture. I will not go too much about that because this is, I think every vendor or SMRs will have the same, which is SMR is a great asset to build in an environment and can produce, as I said, electricity either for the grid or for example, hydrogen production plants or for industry, but also a nuclear station basically is a big boiler. So what you have at the first output that you have is steam, in fact, and you can put this steam into turning a turbine, or you can use this steam actually directly. And this is very well known. This is done all over the world. China is actually building large nuclear units almost dedicated to steam usage. This is technologically not difficult. With small, if we look at the size of the needs of the industries, an SMR is more suited to provide this kind of services than a large power. So from the start, New World is also embarking production of electricity and heat. What makes New World, in fact, different from others? So the first thing is that everything, it is a European SMR. And when I say it is a European SMR, it means several things. First of all, it is based on a European experience that we have, that you all have here in Europe with the European industries. We are not alone on this. We are working with already Italian, Belgian partners, and we are looking for opening this partnership to all European supply chain. It's EU intellectual property, and this might sound, you know, a bit, okay, why are you insisting on that? It means it's not only the design of the plant, it's also, as I said before, the fuel, for example. We don't depend on the authorization or the goodwill or any other country to produce the fuel. Just to give you an example, for example, the Koreans, they cannot manufacture the fuel without some equipment that come from US. If tomorrow Korean and US don't get along, US can say to Korean, sorry guys, you will not have the piece you need. Sorry for you, but no fuel. And then you are stuck with your Korean design, but with no fuel. Okay. The other point is when you need fuel, you need enrichment. You need to take some natural uranium and then you need to enrich it. US, do you know where the enriched uranium from in the US is coming from? It's coming from Russia. They are not independent on that. Europe is. So we have some strong advantages and we should build on that. So we are targeting not a French, but a European supply chain. And we are working on that at the moment to make sure that we have a European supply chain. We are not working to have a French licensing, but a European licensing. And we are already, we have an initiative which is called the Joint Early Review with 6 European safety authorities that are looking at the same time at the same design. And it is adapted to the UA market needs, especially regarding flexibility.
Sorry to interrupt, and we have
yes, I think yes.
3 more minutes. 3 more minutes.
Exactly,
if that's fine.
exactly.
We have the present.
But I was going to say I've taken a bit long. I'm finished. Just one word on this slide side, which is it's important to do things in the right order, not to jump too fast to actually building or claiming you're going to build a fleet if you don't have the basic rights. So you need first to develop the technology. You need to have a first of a kind, and then you need to climb the learning curve and scale up. We are quite honest and quite, I say humble on that, but we think it is important from the start to understand the challenges and to work on, let's say, credible plans rather than selling dreams that will never materialize. So thank you very much for your attention. I'm really frustrated not to engage in further conversation with you today, but hopefully I will come back. Thank you very much.
Thank you very much. There will be future opportunities, many of them actually, because we are planning this series of events. And thank you very much for this comprehensive, insightful presentation. Some of your points on the challenges of decarbonization, powering energy-intensive industry, the resilient supply chain, and the skills development, this will all feed perfectly into our discussion that will follow, one right now and another one in the afternoon. So thanks again for being with us. And I also promise to debrief on the event.
Yeah, thank you. And welcome Slovenia in helping us building this European SMR.